Good morning, everyone. It's really great to welcome you all along to this webinar this morning. We're going to be discussing best practice in passive fire protection, particularly in relation to structural steel and hybrid structures. This is being presented by Architects Journal and run in association with Promat. I'm Jeff Wilkinson, and I'm delighted to be joined today by a stellar panel of panelists. We have Amritha Achutan, Architectural Design Leader at Lang O'Rourke. We have Tom McTiernan, who's the Senior Architect at Falconer Chester Hall. We have Will Cotterill and Liam Keenan, who are both fire engineers and directors at Fire Compliance Plus, and Harvey Brown, who's the National Specification Manager at Promat. So a huge warm welcome to our great set of panelists today, and thanks again to Promat for making this webinar possible. From a building control perspective, I know just how often we get asked questions on this, and it's hardly surprising, therefore, that we have a lot of people who've expressed interest in this. There are over 1,000 people, I believe, that have registered for this, so this is a hugely important topic. Structural steel, as we know, is a component of commercial architecture. It's used in around 70% of our multi-story buildings. And although steel itself is obviously non-combustible, it requires protection from the effects of heat and fire. Otherwise, it can rapidly lose its structural integrity, leading to potential catastrophic failure. There is then the question as well of hybrid structures and retrofits and how these buildings can be protected where structural steel interacts with other materials such as timber and drywall. So, what are the best practices and approaches in fire protection of these various types of design where structural steel is involved? And how can you integrate these into your projects? Well, those are exactly the topics that we're going to be discussing in this webinar. So what is the plan for today? Well, the plan for today is that each of the panelists will be doing a short presentation. After that, I'll be chairing a discussion about the key issues with the panelists, and then we'll open it up for questions from you, our audience, at the very end. So if you would please use the Q&A function at the bottom of the screen in order to post your questions for the panel. So without further ado, let's get it started. And first up, I'd like to invite Amritha to present. Thank you very much. And over to you, Amritha.
Thank you, Jeff, and hi, everybody. Really pleased that we are putting a spotlight on this topic. It's much needed. So really pleased AJ and Promat are doing this session. I'll quickly dive into my slides. Is that now visible? Yeah?
Yeah, we can see
thumbs up. Yeah? Right, so that's me, Amritha Achutan. I presume you are able to see the screen. A thumbs up, please. Yeah, super. That's me, Amritha Achutan. I'm a design discipline leader for architecture at Lang O'Rourke, and I look at all things technical, including passive fire for architectural elements. Now, steel is particularly interesting because steel rapidly loses strength at about 550 degrees Celsius, and that we can see on a fire curve that's to the left. Is attained within the first 10-15 minutes of a fire breakout in a room. So under a cellulosic curve, you'll see that within 15 minutes, steel begins to warp and melt and sort of lose shape. And what does that mean to a compartment? So generally, if there's a compartment fire, you will see that the steel starts sagging, and it has its impact on the slab that it supports, on the dry lining systems and the walls that sit beneath it, and they all start to lose integrity as part of the steel buckling and failing. And so it's really important that to prevent steel from reaching that 550 degrees, we protect it. We delay the heat exposure and preserve the structural integrity of the steel. So clearly that goes on to occupant safety and property protection too. In buildings today, we see that steel is used in a multitude of ways, the wild and wonderful ways, like you can see in the photograph here. Steel, structural steel abuts hybrid, the type of slabs, different kinds of facades. It abuts blockwork, dry lining all around it. And so there's a combination of elements with the hybrid structures in the way that we attend to buildings today. We have steel beams with castellated openings. We have services passing through them. However, the way we apply them today, we never think of them as a system, and that often becomes a problem. And why that's an issue is because our standards have sort of limitations in the way these systems are tested. So while we'll see that the individual steel members, the slabs in itself, the dry lining itself, all of them can be tested to different fire testing standards as part of BS and BSEN. Together, when they come together as a system, you don't have one particular standard which will allow you to test and ensure that they'll all work in cohesion. So that clearly becomes a problem. So individual elements have certified solutions, but no recognized test standards when all of these elements are combined together as a system. And often we lose sight of this when we design it and put it together in a building. So one way of attending to this in my experience and amongst projects that I've worked is to sort of have a checklist to go to attend to, and clearly early planning for, for these different elements coming together in combination is key. Awareness around them is key. So what I've tried to do here is put together a sort of checklist to address these concerns. Clearly, we have deflections and fire load deflections, which are never sort of attended to in the movement and tolerance report. So it's always advised that once we get into a project, let's request from the structural engineers that we get fire load deflections as part of the building's movement. Sometimes it's difficult to define that, and in those cases, we kind of define the maximum limit to which the building can be allowed to move in a fire state. So that can be limited through fail safes, like it's been done in this particular detail. So you restrict the movement of a building beyond a certain particular degree, level of deflection. Have critical steel temperatures defined. Now that helps to sort of define your pacifier protection. Your section factors are defined on the basis of, and that the critical steel temperatures then gives you what the protection looks like to that particular structure. Define your hybrid system. So given that sustainability is a big criteria now, modern methods of construction is the way to go. We always look at structures which are not very common, which are not traditional, which are not defined as part of our standards. So how do we address metal deck slabs, riser modules, metal edges to slabs, composite slabs? So it'll be good to see if there are tested systems available for them. Now, clearly, the systems design is one that gets a lot of attention. If we, and typically this is seen in buildings where we have, let's say, a commercial floor plate where we have a riser block sitting right in the center, which are often, covered by shaft walls. You have fire doors inside them. You have penetration seals above it, and then perhaps castellated beams through which we have services passing through them, all topped with a composite deck. And what's often noticed is that all of them have individual test standards and are certified, but none of them together will have a tested solution. So it becomes really complex in a situation like that to try and get some sort of compliance or assurance around the build. Awareness of it is definitely helpful. And once we know that, we can approach advisory notes from ASFB and from the SCI to help us guide to some direction and ensure that it is designed in such a fashion that integrity and insulation are maintained in cohesion. But what's advised is that when we have cellular beams, let's try and place them away from the building line, the grid lines. Very difficult to do, but with some early planning that can be achieved. So avoid cellular beams and compartment lines. Try and place your MEP services completely within walls, within dry lining partitions or blockwork, but not within the structure, because you'll find very limited data to get the two as a compliant detail. Similarly, secondary supports need some attention. You'll often see that secondary supports supporting fire doors, supporting facade panels might need protection. Let's ascertain from our structural engineers and the fire engineers as to what level of fire protection we're driving for these. Review these connections with respect to tested information. And of course, as part of your overall projects, always try and identify untested details so that we define a compliance approach, especially in today's landscape. Yes, seek advice around untested and bespoke detailing. Yeah, so those are the high level pointers that I'd start off when we try and look at buildings. Like I said, awareness is key. The minute we know there is good industry practice out there, which defines and which directs us to the way we should be doing. The Yellow Book from ASFP has got a lot of guidance notes, advisory notes. SEI, which ADB refers to, is got some good guidance. Of course, there's PFKG, which is a forum of tier 1 contractors who come together and put together real building problems. So structural steel interfaces is one of their knowledge shares, which gives us really good recommendations. Yeah, so that would be my list of go-tos when I start looking at structural steel in buildings, and I hope that's useful. Over to you, Jeff.
Thank you very much, Amrita. That was a really good initial encapsulation of the issues I think that we're all facing. What I'll do now is I'll introduce Tom. Tom, if you could get your slides ready to go, please, that would be great.
Yeah, thank you very much for the introduction, Jeff, and thanks, Amrita, for the talk. I'll just share my screen here. Okay, so my name's Tom McTiernan. I'm a senior architect at FCH based in Liverpool. I've been involved in several high-profile developments, including Thornton Park and Bridgewater Street, and multiple regeneration projects across the northwest and London. So through working on some of these projects, I've gained experience of specifying steel protection, some of which I'm going to talk about today. So for this brief presentation, I'm going to be focusing on key lessons learned, and this includes things to look out for when approaching a project with a steel frame, particularly where this interfaces with an existing timber floor, for instance. I'm going to look at a retrofit project as pictured, which is the retrofit of a 4-story existing furniture factory with a 3-story zinc extension on top. So with regards to steel protection, when considering a typical perimeter beam slab edge arrangement as pictured, some of the key considerations are the junction with the SFS. Is it tested? Does it need a Z bar? And this will depend on the steel size. Is it going to be exposed to the elements during construction? For instance, when does the shielding board actually go in? And if it is going to be exposed, you require a specific board which can be exposed during construction. What test data is available for this junction, i.e. between the boarding company and the SFS? Some companies will have tested SFS with boarded steel to see how it reacts in terms of loading capacity, etc. For this scenario with a composite deck system, do the deck cavities need to be infilled as indicated? This will need to be agreed with all parties to ensure that the project is compatible. So another approach to steel encasement could be painting the steel. However, a number of manufacturers require circa 50 to 70 mil expansion zone, which could mean that you need to form studs around the beam, which could be a costly option. So when specifying steel encasement, you'll need to work with the boarding manufacturer and fire engineer to agree the boarding spec for each column and beam, i.e. the type and the number of boards required. This will be dependent on the steel section factor and the limited steel temperature, which the structural engineer would confirm, the level of fire rating and compartmentation required, and is it insulation and integrity that's required, which the fire engineer would confirm. Hence, a full schedule of steel, beam and column sizes for each scenario to which to be installed is required. And it's also very important to establish primary and secondary structure. So, the other point is consideration is required with regards to the interface between painted beams and boarded beams, and these overlap principles need to be agreed generally based on AFTP guidelines. You'll also need to consider, do services need to pass through the beams? And if so, they cannot be boarded. So in consideration as regards to whether the cavity barriers or fire stops abut the areas of boarded steel. So you'll need to establish what fire rating is required, and the boarding will need to match the cavity barrier performance. This could result in secondary steel elements needed boarding to support the cavity barriers. For this project, we retained the existing floors and joists and boarded the existing beams. So when working with an existing timber floor, careful consideration is required with regards to how the existing steels interact with the existing floor, which systems are tested and which elements have not been tested. As per the diagram on the bottom left, for this instance, we had a tested system for the floor and a tested system for the beam encasement. With regards to the interfaces between the two, the arrangement was agreed with the fire engineer based on the limiting temperature of the joists, which was circa 300 degrees, the limiting temperature of the steel, 500 degrees, and consideration of at what point the wood would char. So, as mentioned previously, sequencing is important so the contractor understands any potential major implications required, like lifting the floorboards. On this project, following fire engineer and boarding manufacturer review, this wasn't deemed necessary as we were able to board around the joists in place. Junction details with internal walls need to be considered, and some manufacturers will have junction details between walls and boarded beams, which can be followed. For this scenario, a fire stop was deemed necessary in the floor to retain the compartmentation also. So the process of encasing the steel relies on having a fully resolved structural model from the steel fabricator. Watch out for bolts, stiffeners, and plates being added at the last minute, as these can result in extremely tricky boxing out details. We'd strongly recommend that the manufacturer come out and assess the boarded steel to ensure that it's been installed as per their recommendations. And the final consideration is bracing, to make sure the coordination is carried out with a structural engineer and steel fabricator to ensure that there's enough room for boarding, as the bracing may need to be offset. So I guess just in summary, in consideration of the gateway process, it's really important to collate all of the test data available to build a strong case in your compliance statement, particularly for unique untested scenarios which arise within existing buildings. And that concludes my presentation.
Thanks a lot, Tom. I think that's a perfect example of the kind of issues that we face in the reality of the construction world on a daily basis. I think that's a really, really good example of the kind of issues people are coming up against on a daily basis. We've kind of heard already from the contractor, we've heard from the designer. Let's now swap over to hear the views of our fire engineers. Will and Liam, can we hear from you, please?
Absolutely. Yes, and thank you everyone for joining this morning, and thanks to the team for extending an invite for us to take part in this. I'll just quickly share the right screen. Okay, is that showing? Yep, perfect. So my name is Will Cottrell. I'm the Technical Director of Fire Compliance Plus. We are a passive fire protection consultancy firm. We work alongside many tier 1 contractors all the way through down to the likes of healthcare providers and directly with fire stopping contractors to help provide a route to compliance. This could be for new builds or remedial works in historic buildings, which are not necessarily built to modern standards. So when we talk about steel protection, there are a few variables, different ways to approach it. If we're looking to just protect the steel on its own, then there are methods such as incandescent paint, which can help with the structural integrity of the steel. But as touched on by both Amrita and Tom, these don't necessarily achieve an insulation value, which can then obviously affect compartmentation. So when this occurs, typically would look down an encasement route for the steel. There are certain circumstances where you may have to combine a number of systems. However, this should be avoided if at all possible, and a single system or single manufacturer should be adhered to. So when trying to calculate the correct approach to the structural steel, we would use the section factor or the A over V calculations based on the steel dimensions, the required fire resistance period, and also the limiting temperature that is need to be retained to protect that steel. There is many articles out there and some good literature available from the likes of the ASFP and others, as pointed out earlier. When we then look at the slightly less typical elements of steel protection, we have things like cellular beams. There is currently no harmonized standard in which to test cellular beams. And again, any testing methodology around steel doesn't necessarily align with your typical fire stopping for mechanical and electrical services. So where this occurs, it is often a bespoke approach. Again, many ways to tackle this sort of scenario, but effectively at an early stage during the design of the building, this should really be avoided if at all possible. The same with steel interacting with compartment lines. This again would go on to the topic of encasements and steel protection paint, and which is the most suitable. So where steels interact with a compartment line, to retain the compartmentation and insulation value, this is where we would look at something more like an encasement system. Another topic that seems to be coming up quite a lot in recent times is steel beams with timber interface. This has come up quite regularly in both new construction and remedial works in older buildings. There are some additional considerations to be made for these sorts of scenarios. Of course, the steel starts to lose its structural integrity around the 500 to 550 mark, but of course, timber will ignite at much lower temperatures than this, depending on the type of timber used, of course, and the moisture content. So where this occurs, again, it would be something more along the lines of an encasement system rather than a painted approach to retain some of that insulation value. Of course, when combining steel and timber, it's very, very important to make sure that there are not other avenues to take that are either directly tested or a lot closer to tested. So again, in a new build, if this can be designed out in the early stages, older buildings requires a bit of a further look into and a further consideration. One thing to note is early engagement, not just for steel protection, but for all elements of passive fire protection. It's very important that the relevant design team, manufacturers, fire stopping contractors are all sat around the table in these early stages for the design phase. This can also, not only can this be costly later down the line for things like technical assessments and engineering judgments to be provided, but also the time implications involved in that. And it isn't always guaranteed that an assessment or a judgment can be provided. If the scenario poses certain elements that there is not relevant reference data for, it may be that not only is there a cost and time implication, but it might not actually be achievable. And then, of course, that's something that we all would like to avoid, is carrying out remedial works on such a large scale. Other elements to consider as well in these scenarios is where test methodologies do not consider certain scenarios, that this is picked up as well in these early stages, again, to avoid those same complications. This also then has a knock-on effect to the Gateway 2 as part of the UK Building Safety Act 2022. Again, the coordination is really key in the early stages to try and avoid these technical and financial implications, as well as the obvious safety aspect. If in the early stages there are manufacturers, specialists who can help, it's key to ensure that primary data is available. So things like ETAs, formal test reports, things like that are available, not to just go off data sheets. And that is my final slide. Thank you for your time.
Thank you very much, Will. Really useful insights throughout there. One thing I have been made aware of is that it would appear that several people have been locked out of the meeting today due to us being at full capacity. I told you this one was going to be hugely popular. Don't fret, though. Let all of your colleagues know that the recording will be made available after today's event. We will contact everyone that's registered and make sure that they do have access to watch this afterwards. So don't stress too much. But those of you that made it through, make sure that you spread the word to your colleagues. Okay, so that brings us on now to our sponsor, Harvey Brown from Promat. Over to you, please, Harvey.
Thanks, Jeff. Morning, everybody. I'll just share my screen now, get the presentation up for you. Everyone see that? Oh, sweet. So yeah, it's good to hear a mix, a sort of mixed perspective when it comes to structural steel fire protection. So obviously we've heard from an architect, main contractor, and a fire engineer. So I'll be speaking more on the position of a manufacturer. So those of you who don't know who I am, my name's Harvey Brown. I am the National Specification Manager for Promat. So I look after the specification team here in the UK. Been in and around the passive fire protection industry now for around about 8 years, with 6 years at Promat. Currently a member of the Institute of Fire Engineers, associate level, and have a Bachelor of Science honours degree in fire and rescue. So yeah, like to think I've got quite a good wealth of knowledge when it comes to fire protection, and in particular passive fire protection. So what are the main challenges really when it comes to structural steel protection? So the main key topic, which I think it's been covered quite considerable, quite good detail already on this webinar, is that testing doesn't necessarily match the reality, and test standards are even more so, are becoming even more limited in terms of what we as manufacturers are able to test to. So there are a set of test standards that we can follow when it comes to structural steel fire protection. It won't cover every single given scenario on a project. It won't cover the things like interfaces, penetrations, etc. So, like I say, as a manufacturer, a lot of manufacturers coming under more scrutiny recently in terms of trying to provide as much evidence as possible for these types of scenarios. We're being challenged on things that maybe from sort of the last 5 years or maybe before that we weren't being challenged on previously, and things like assessments were being accepted and desktop studies, and that has all changed. We're in a completely different world to where we were at sort of a couple of years ago, and we as manufacturers, I think, are being seen as the area where we've got the people at play, where we're going to try and figure out how we fill these voids that current test standards don't allow us to test to. So, for example, on steelwork protection, compartmentation, there's no current test standard for that. There's no test standard for interfaces between the likes of steel and SFS, which has been talked about already today. Deflection, how do we deal with deflection in a building and try and also give a fire resistance to a given structure? And correct limit temperatures. There was a question in the chat which I answered a second ago on how would you find out what the limit still temperature is, and it needs involvement from other parties. And I think the key thing with this webinar today is it goes over there needs to be collaboration, there needs to be early engagement on these projects to ensure that all the correct information is in place so that the correct specification can be put forward. What else has changed? So there's been a big change in the legislative world at the moment. So Approved Document B launched their most recent revision in 2019. And the biggest changes that you would find really from that document is ultimately there was a big emphasis on British standards pre-2019, so from 2013 onwards, and EN was sort of put into the appendix or in the footers as an option if needed. It didn't really give any clear guidance on whether you needed to classify a product or a system. No reference really to extended application standards, and assessments were typically allowed to be used at that point. Come to 2019, the changes have pretty much flipped on its head. EN test standards are seen as the go-to test standards now and are seen as being more onerous. British standards currently are still within Approved Document B and are still in the footers and the headers. It's likely, though, that what we're seeing is that by 2029, it is expected that all manufacturers' test data, when it comes to fire protection, will be on EN. It's very likely that British Standard is going to be removed from Approved Document B at some point in the future. And we've been given a date of September 2029 to make sure that we've fully moved across to EN, and that will be for all manufacturers in this region. It gives clear guidance and states that classification is needed, it's required. So you have to classify your products and your systems that you're testing. There are reference and guides that can be used to extend the data that you've got. So a good one outside of steelwork is on petitioning. There's the XAP rules that can be applied to extend heights on petitions. There's ways of extending the depths that you have covered after tests on the likes of a steel encasement system. And third-party testing and assessment is being seen as the way to go forward, or classification. And assessments are now becoming very limited. They're not being accepted anymore. And test laboratories themselves aren't willing to really push forward and do those anymore. They want to see a test behind whatever you're doing going forward. In addition to that, we've had obviously the Building Safety Act, which came into act in 2022, which has given us a guide on how to go about designing buildings in terms of fire performance going forward. And a key change here really is that fire is now being brought to the forefront to design, and design is going into more detail now in terms of fire at an earlier stage. So Gateway 1, your fire design needs to be really thought about. And off the back of that, architects are needing more assistance, main contractors are needing more assistance in terms of detailing earlier on in the project. So there are some challenges that we all as stakeholders and players in this industry have to overcome as part of these changes. And the major one would be the fact that, as I said at the start, testing at the moment doesn't match the reality of what is going on projects and on sites at the moment. So what needs to happen from a manufacturer's perspective? So the way we see it in terms of Promat E-Techs and the way we see a lot of other manufacturers going down is that there's going to have to be a lot more ad hoc testing going on in the background to overcome the gaps that are left behind by test standards. So I thought I'd just bring on a couple of examples of what isn't covered in a test standard and what generally requires ad hoc tests. Some of these have already been covered off earlier today in the other presentations, but for steel encasement systems, compartmentation, there is no current fire test standard that deals with compartmentation on a steel encasement system. So the way that you would typically go about doing this is you would test it as if it was a petition detail, fixing boards to a 50mm stud, which in all essence would be more onerous than if you were to test it on a thicker piece of steel. So that's a way of trying to prove some base data on that. It's not necessarily directly tested as a steel beam encasement, but it's more onerous. Deep beams, typically you test in a 3x3 meter furnace. You apply a load under these test conditions. The biggest problem with trying to test beams over that amount of a load on top is that you can't physically get a load big enough on top of a test rig to give the amount of deflection needed on a bigger steel section. So typically you are limited to normally a 457 deep beam when it comes to the test standards. And then when you extend after that, you typically go to 600 mil. So if you check most manufacturers' test data, you'll probably find that the majority of them will only ever go to a 600 mil depth. Some, including ourselves, will have data to go deeper than that. And we've done that via using different facilities across Europe, across the world, where you can go to bigger test facilities that allow to have that, the greater load applied, or unloaded tests that will prove the principles of a bigger encasement system. Cellular beams, which was also covered earlier in the presentation, there is no current recognised test standard. Although, however, I have heard that potentially there might be an EN test standard that may be coming soon to test to. So how do you go about doing it? So again, it comes with that collaborative work with the test houses to try and come up with a way of doing a test to that. Now, generally, you're going to follow the principles of a standard universal beam fire test, but you've got to adapt it so that you can match the exact application and solution you're looking for. So you can see an image down the right of an encasement system with a fire stop in to allow services to pass through compartment lines. So these are a couple of examples that we come across quite regularly on schemes where we need to try and overcome those gaps, and we've been able to, and other manufacturers are also following suit. A real key one at the moment that we get asked quite a lot of questions on is partition interfacing. So your partitions test standards will be from concrete to concrete. Your steel encasement standards will just be a 3-side box around a steel beam, 4-side box around a column, which there are annexes and appendices within the EN test standards which allow you to extend that out to things like square hollow sections, CHSs, PFCs, etc. But there is no recognised test standard for where these two elements meet. So ultimately, if you really wanted to provide some evidence on that base data, you're going to have to go and do an ad hoc test. So we've done that with Promat and Cineat. Again, I think some of the manufacturers are following suit now as well. But the key thing here ultimately is to understand that there is no recognised test standards for these types of arrangements, and it then creates a challenge to try and provide evidence and to try and provide suggestions on what would suitably work. Obviously, the first point of call is to go in ad hoc tests. And I think most manufacturers are going to have to go down that route now and bring about more ad hoc tests to try and prove or give some base evidence that we can then pass on to a design team or a fire engineer for them then to do a technical assessment. If it's not needed, then obviously it just needs to be recognised ultimately that there is no test standards for these types of applications. So the key takeaways really, I think, from my presentation and the other guys as well, ultimately, is as a manufacturer, we're limited to the test standards, but there needs to be more ad hoc testing going on, and that is what I think a lot of manufacturers, including ourselves, are looking at going forward. I think an education piece of webinars like this today are good because it's good to educate people on the likes of testing products and systems and the test standards. A lot of people know that that certain applications and interfaces aren't covered by test standards. Early engagement, that's been a key topic I've heard in the webinar so far. That is considerably key going forward. We like to be involved with you earlier in a project rather than later on, so these issues can be overcome before it gets too late in that cycle. And collaboration needed between all parties, design team, manufacturers and fire engineering practices, to try and overcome the gaps where maybe a test standard or even an ad hoc test can't be done to overcome that. And we've seen some real benefits of some of the schemes we've worked on where that has worked really well. And the key point I want to put on here is, manufacturers like ourselves, we don't have all the answers. And I don't think anyone on this panel will have all the answers right now. But the key message is effective collaboration is needed going forward to help develop and to close those gaps up. That's the key point I wanted to get across today. I look forward to answering any questions that anybody's got at the end. So thank you very much. Back to you, Jeff.
Thanks very much, Harvey. Again, excellent presentation. I think it's very clear from what we've heard from all of the panelists today that the level of detailing and the level of understanding that's required on projects now moving forward has completely changed from what it was pre-Grenfell. Whether these are HRBs or not, whether they're going through Gateway 2 or 3, or whether they're just going through the standard inverted commas building control process. I think if I can start with Tom, just picking up on that particular point, how much extra effort and time do you feel you need as the architect or the principal designer on a scheme to actually be able to incorporate this in at an early enough stage?
Yeah, I feel that's a good question. And we've had a few projects in the office where we have gone through this rigorous process of steel encasement, along with Promat and Saniat. And it has certainly taken a lot of extra time, and it would be incorporated generally within the stage 4 process. But depending on when clients want to go to contractors, for initial pricing, it is worth bearing in mind that some of the boards, particularly Vermiculux board, is quite expensive. So it's something that contractors want to know about early. So that's another consideration. So yeah, both it has certainly been since Grenfell, it's got a lot more rigorous, the process. So the time spent has certainly increased. So that is something that architects should bear in mind when taking on steel framed building. And I think certainly, there has been instances where contractors have considered doing a building in steel, and then when they've looked at the cost implications and these detailing implications, they've changed to concrete because that's potentially an easier path.
I mean, obviously that has huge implications very, very early on in your gateways 2 and 3 process.
Yeah.
And Retha, if I can perhaps bring you in from the contractor side, how much information do you feel you're getting? And are you getting it early enough? And do you find yourself having challenges such as Tom's suggested, where literally we're going to change the entire structural format of the building? The effects that must have on the design process would be immense.
Absolutely, Jeff. So it's been a learning curve for us, and like Tom alluded, since a few years we have changed the way we try and get information from our consultants and our structural engineers and our fire consultants, because we realize there's so much of information that might be needed to get to a robust and compliant design, which we currently, as traditional design, we don't really have sight of at stage 3, at stage 4, and even later down the design. So we sort of need to get into the finer details of construction level detailing to be able to assure ourselves of what the final design and installation will look like. So it's been challenging. We don't really get a lot of information. So there's been a lot of focus on design responsibilities, closing out final design, and we're trying to move all of that further ahead into the program, and sort of again the focus on early planning and early engagement with manufacturers and suppliers has been of utmost importance lately.
Yeah, I think that's kind of coming across strong and clear throughout it. I think one of the questions, and perhaps I'll go to Will in this, is whether or not the contractors and the designers actually have sufficient understanding and knowledge of these systems and the involvement in the designs, and to what extent you feel you really need to be drawn in as the fire engineer into some of these really quite detailed elements, rather than just a sort of like a global fire strategy kind of approach, which is historically what we've kind of expected from a fire engineer, but much more into this kind of level of detailing.
Yeah, absolutely, and of course it can vary from project to project. But from my perspective, from our perspective, the earlier the better. If we can get involved in the early engagement to try and iron out potential issues, it's the old saying: "Stitching time saves 9." Of course, depending on the project requirements, it may well be that additional services are required from the structural engineers, And again, in older buildings, trying to obtain some records from the original construction can be difficult, and in some cases can't be provided. So it's even more important in those scenarios to get involved as early as possible to try and advise, you know, the best approach to try and find the right route to compliance.
Excellent stuff. I can see that Harvey's sort of typing away there, but I will switch across to Harvey now, because we've gone through quite a lot of explanation so far about the importance of the detailing. Let's deal with the classic elephant in the room on every specification that we see or similar approved. Just how much of an issue is it, and to what extent should those listening understand that, you know, once you've gone through this level of design and detailing, that it's not a simple process of going, well, actually, we can just swap that product A for product B.
Yeah, I mean, it's a very common occurrence, and yeah, the main issues with that come from, there's obviously a technical aspect to it and obviously a cost aspect to it. Now, from a technical perspective, like I've mentioned in my presentation earlier, there are certain boards tested to do certain things, and certain board types have different properties. So some boards can be used in wetter areas, some in dry areas. So with steering cases, we do see it quite a lot where they try and maybe change out some of our board specs for like a standard plasterboard system, but the plasterboard system that's in place, it might not necessarily have the same data available, might not have been tested in a similar scenario, might not be suitable for the environment that it's going into. So that causes issues further down the line. And when you're going onto a project site and it's not watertight, for example, and you've got a plasterboard around steel and it's getting damp and wet and mouldy and you're having to rip it all off again to do it. So that then comes with a cost implication at the end of it. And I think that's also one of the positives really of the Building Safety Act is it is trying to remove that last minute of changing of systems. A really good example was a car park project I was involved with a few years ago, where essentially a plasterboard system was specified at the time, and then they came to us sort of later in the day, towards the end of the design stage, to look at a system. Now we put forward our vermiculite accessible because it's a semi-exposed environment, so it can take the moisture. Now the price difference between the two boards was a lot more, so there was then real cost implications at the end because it hadn't been considered earlier in that stage. So yeah, it's one of those things that, and the key point that I really want to push across is about early engagement. And the sooner you get people like ourselves involved on calls, the sooner these issues get resolved, and explained as to why that system is okay. That system might be more expensive, but this is the reasons why it's been specified.
Excellent. Okay, so I think what I'll start to do is I'll start to open it up to some of the questions that are being asked by our attendees today. Now, just bear in mind to say that there are hundreds of you and lots of questions. We're not going to have time to take them all, but we will do our best to provide responses following on. One thing that I've noticed and picked up by one of the questions is the approach that the building safety regulator is going to be taking to this, particularly when we come to Gateway 3. And I think we'll open this across the panel, so if anyone wants to jump in on it. But obviously we're not yet, for the majority of cases, at Gateway 3. What are you doing to ensure that by the time you get to Gateway 3, you're going to be satisfied that you have the evidence in place? And particularly picking up on what Harvey was saying, if you've got an ad hoc detail, or you've had to change something or something unusual like Tom was suggesting, how are you going to be presenting those to the building safety regulator to have confidence that you're going to get a completion certificate? So I'll start off... I think I'll start off with Tom from the design point of view, run to Amrita, and then open it up generally. So Tom, from the design point of view.
Thanks for the question. Yeah, so basically in terms of the Gateway 2 application, for us, the key document and all this would be the compliance statement. And basically it would be, during the stage 2 or during that process of that application, trying to gather all of the test data for each of the, and particularly on the unique scenarios, and have a clear narrative for our approach, which has buy-in from the design team, particularly the fire engineer and the boarding manufacturer. I guess in terms of an existing building where there's elements that you're going to be opening up along the process, it's a very good question, you know, with regards to Gateway 3, and if there is elements that do require, you know, a change request and notifying building control about this detail. You know, for instance, when we've opened this up, this has to change. So I guess we would need to take a judgment on whether that warrants, you know, contacting building control, whether it's a major or minor occurrence. And then in terms of monitoring installation of the boarding to make sure that it's been properly installed, it was, as I mentioned, would strongly recommend getting Promat or the manufacturer involved to check it's been installed properly.
Yeah, Amrita?
I would agree with Tom. So our first take is always to try and align a detail with tested evidence. So in early stages of design, it's always easy to try and get your design as close as possible to tested evidence, make it indicative of what information's out there. So clearly that means engaging with your manufacturers. But say in an instance where the detailing is rather bespoke or it's a retrofit and you have got to modify it, go through down that process of discussing it with all the key consultants to see how we can get it to closely align with whatever test, primary test evidence there might be. Get a path to compliance through discussions with all your stakeholders. That's client, architect, fire consultant, structural engineer, all of them involved, to understand whether they're all happy with the process that's been taken, the final design that's been come to, and when there is a combined consensus on a way forward, and there is good evidence to back that that this is very low on your risk radar. That's promising for the BSR to sort of look at and take it further. So that means that you've done enough work to ensure everything that is justifiable has been done through with that design portion. Of course, that could be in form of technical notes from fire consultants with backup evidences. It could also be alluding towards a bespoke test, which needs to be done within the program time frame before you present evidence to BSR. So that's a route that we would suggest. So multiple layers of way to approach a problem.
No, that's great stuff. In fact, what I'll do is I'll just jump in here. Sorry, Liam.
Yeah, Jeff, it was just on that point. I think so Liam Keenan here, I work with Will Cottrell at Fire Compliance Plus. Within regulations, so within approved document B, there is a pre-existing route to compliance where there isn't tested solutions. So there's a guide within the industry called the PFPF guide, and that's the guide to undertaking technical assessments in lieu of specific test data. That sets out a competency framework. It sets out a rigor and a route of using, as Amrita was saying and as Harvey was saying, as close as test data as possible, but undertaking an assessment by a competent person to prove compliance with the detail. So taking one of the examples that's come up a couple of times with cellular beams on compartment lines. So Promat with other members of the ETEX family within FSI, they've done some testing with cellular beams protected with Vermiculux S, and then the infills with the FSI stop seal bat. So they've got some blank seal test data with that combination, and like Harvey had touched on, they've also got compartmentation data with using Vermiculux as a structural as a partition system, sorry, and it's using those test data as part of an assessment to justify the performance that you're trying to achieve, and then looking at those services and combining all those test data into a package that is under the remit of that PFPF guide and providing an assessment that meets the functional requirements of that guide, and therefore meets the functional requirements of approved document B.
Great stuff. Really interesting question that has come up, which I'll definitely put, I think probably to Harvey in the first instance. Obviously, we've been talking about HRBs, we've been talking about the gateways. Several of the people on the call today are actually just working in a small practice. They don't have access, and certainly the project wouldn't fund a fire engineer on there. For those architects and those designers, what approach would you suggest that they use? Who can they get involved to get the support that they need?
Uh, Again, it's a collaborative effort. So I mean, ultimately, you've got to speak to the manufacturers first and foremost to see what data they have. You know, and I'd love to say for you all to come to Promat, obviously, but you know, we're not going to have all the answers. There'll be certain manufacturers that will have other answers to certain things that we won't have, that we don't have, and vice versa. So I think the first point of call would be, you know, go and speak to your manufacturers that you deal with, or that you maybe don't even deal with, and just see what data they've got first and foremost, because they might have something in the background. And then again, working with the manufacturer, architect, the main contractors together, to try and come up with a best possible way of looking at something based upon the base data you've got, I think is the second point of call. And then I think ultimately, educating those who then are responsible for looking at sign off of works, whether that's a building regulator or someone to show like this scenario hasn't been tested as a combined effort. This is a solution we've come up with. This is probably the best solution we're going to be able to give over to you that hasn't got a test standard to it. Get their thoughts and opinions on it. And you know, we've worked on schemes as well and with Fire Compliance Plus where we've had to then recommend, look, if it needs more backing, it ultimately needs to come down to whether or not, you know, ultimately if someone's still happy to sign off even though it's not got the direct test, or it then needs to go down the technical assessment route. And then it does come to that point where you have to start considering at an early stage, what do we need to get a third party in here like a Fire Compliance Plus or another fire engineering practice to try and help us overcome the issue we've got maybe with a technical assessment. So I think there are ways of going about it first. It's for that instance, if I say, especially if funding and money is a bit tight, but worst comes to worst, if it's still not at the point where it's still going to be signed off at the end of the day, it does need another third party to come in my opinion, and look at trying to help out.
I'm going to take a guess at where this question was actually coming from. I think that historically, a lot of what has happened is you would go to building control and basically go to building control. Are you happy with this? And obviously the responsibility now lies, if it's a design issue, it's the principal designer's responsibility. If it's an installation issue, it's the principal contractor's responsibility. But one of the things that certainly I constantly hear is that historically manufacturers produced catalogues of approved details, for example, and they're far harder to get hold of. What can be done to make this information more available to the smaller architect that's working on the smaller projects? Anyone? Jumping on that?
I don't mind answering. I mean, ultimately, from a manufacturer perspective, more needs to be done in terms of, I suppose, digitalizing what we've got and putting it out onto a digital platform. So again, we're not the only manufacturer doing something like this, but from our own experience, we've got things like My Promat, My Cineac, My eText that we brought out, so anybody can go on and log into an account and can start downloading standard details, technical data sheets, etc. So I think there's still more work to be done on a digital perspective. Obviously, NBS as well. NBS comes into play. There's a lot of work going on with NBS at the moment.
Unfortunately, I can see that we're fast running out of time. What I'd like to do is to just quickly run around the panel and just for your a literally 10-15 second, what's your key takeaway from today? What was your key learning? Tom?
Get consultants on early.
Yep. Amrita? Sorry, you're on mute. We would never get through a webinar without saying it at least once. Could you unmute yourself?
Apologies. Early engagement, I'm with you.
Will?
Again, early engagement and also collaboration. You know, different manufacturers, different consultants. In some ways, we're in competition with another, but we're not. We work together a lot. So collaboration as well.
Excellent stuff. Liam, anything you wanted to come in with?
Yeah, I mean, everyone's banging the same drum of early engagement, but I think, like Harvey was saying, like Amrita was saying, Tom was saying, that if you're unsure, ask. The manufacturers try and condense these complicated test reports down into standard details, but they still require interpretation. The manufacturers, at the end of the day, are the experts in those systems, and they should always be the first port of call when you're asking any questions. And if anything is unclear, ask.
Absolutely. Harvey?
Yeah. I mean, collaboration, and ultimately education as well. Just make sure you're continuously learning about how things are tested and how products work, etc.
I think from my perspective, I'm going to go slightly different. I think that trying to adopt an approach of standardization first, wherever possible, look for look for a system that you can have confidence in. If you can't have a system that you're confident in, then make sure that you're speaking to the manufacturers and make sure that you really identify what the potential risks are. It's been an amazing webinar. Thank you so much for all of our panelists today. Thank you everyone for attending. Thank you for the questions. We got through a fraction of the number that we had. Thank you particularly to Promat for sponsoring today's session. And just to confirm once again that a recording of this session will be available if you pop along to the AJ website to find out more, where you'll also find out about the AJ masterclasses that are coming up. So please book yourselves on those as well. Hope you enjoyed it. And that's been everything for us. For those of you that have been, I thank you for listening. I've been Jeff Wilkinson. Thank you and goodbye.